Solve radical equations. So we have an equation, but it contains radical in there. Example 1, square root of 2y plus 3 minus 4 equals 0. So when we get an equation like this, radical sign, we want to get rid of the radical sign. And that goes back to something we learned before. If I have square root of, let's say, square root of 5, and if I square root of 5, and that means square means 2 copies, square root of 5 times square root of 5, and that gives us square root of 25, which can be simplified to a 5. So that gives us the idea. If I square anything, so you say, let's just put an x there. When we square it, that's going to give us square root of x times square root of x. And that is square root of x times x. Both x are with the radical sign. We can multiply them and 2 copies and can come out to get x. Because square root, if you remember the definition, it means x squared is the square of which letter? Of course, x squared is the square of x. Or in other words, you take 2 copies of anything out. Now, so that tells us if you want to get rid of square root, you can square it. But be careful, you can only use this when you have an equation. If you have a fraction like this, for example, 3 over square root of x, you cannot say, okay, let's go ahead and square the bottom and square the top. If you do that, you change this fraction. This fraction is squared. So for example, if you have 3 over 5, when you square the bottom, and you square the top, you can get a 9 over 25. That's not going to be equal to the original fraction 3 over 5. So 3 over 5 is not equal to 3 squared over 5 squared when you increase both numbers. But 3 over 5 will be equal to, if you multiply the same number, say if you want to multiply both top and bottom by 5, you get 15 on the top, 25 on the bottom. This is correct. But you cannot, when you are given a fraction, you cannot square the top and square the bottom. They're not going to be equal anymore. And so that's why when the problems we learned before, try to get rid of the radical sign in the denominator, or we also call it rationalize the denominator. And you cannot square the top and square the bottom. You have to multiply the same thing, both the top and the bottom. When you do square, it's more like 3 times 3 on the top and then square x times square root of x on the bottom. When you multiply different numbers, 3 and the square root of x, they're not the same. When you multiply different numbers or variables, you're not going to get the same fraction anymore. But if you multiply the same number, say 5 and 5, after you reduce them, you can still go back to 3 over 5. So be careful, just side note. But the good thing is, if we have an equation, let's say I have 3 over 5 equals, let's make it 6 over 10. I can square both sides. When I square the left, I got 9 over 25. And then I can also square the right. I get 36 over 100. And when you simplify them, you're going to find out they're still the same, because let's say divide both top and the bottom by 4. 100 divided by 4, it's 25. 36 divided by 4, it's 9. They're equal. Because when you have an equation, the left-hand side and the right-hand sides are equal. So whatever you do to both sides will still keep them equal. You can add the same number, subtract the same number, or multiply the same number, or divide by the same number. You can even square both sides. And you will get left-hand side squared. It's still going to be equal to the right-hand side squared, because this is an equation. Well, when you have a fraction, it's not an equation. It has a top over the bottom. When you square the top and the bottom, it's not going to keep the same fraction. The this is not going to be the same as top over original bottom. But if it's a equation, you square the left, square the right, they are still going to be equal. Okay, so make sure you remember the difference between a fraction and an equation. So now we can go back to solve this radical equation. So what we're going to do is try to square the radical, but make sure when you square it, there's only a radical sign. There's no plus or minus. In this case, we have a -4 here. If you square that directly, it's not going to get rid of the radical sign. The only way you will get rid of the radical sign is you can only square the square root without a plus or minus anything there. So first of all, we want to get rid of this +4 there, -4 here. We can add a 4 to both sides, and that will give us square root 2y plus 3. Cancel them, and equals a 4 on the right side. 0 plus 4 is 4. Now we can square both sides, because there's only a radical sign by itself, no plus or minus number on behind it. So when you square a square root, so this square right here and that square root, they sort of cancel each other. They are inverse operations. And just like what I showed you before, when you take the square of this square root, you're going to get whatever within the radical sign, which is x. Square and square roots, you're going to get just the 5. So the same thing here. When I square this square root, I'm going to get whatever within this radical sign, which is 2y plus 3. So it's sort of like, you can think of this as this square cancels that square root. And equals 4 squared, it's 16. And now we can solve y. 2y equals 13 divided by 2. So y equals 13 halves. And for radical equations, just like rational equations, you must check your answer. So you can plug 13 over 2 in here. 13 over 2 times 2 is 13. 13 plus 3 is 16. Square root of 16 is 4. And 4 minus 4 is 0. Because when we square both sides, we might have some fake solutions. So you have to make sure you check your answer. Plug back into the equation to check the answer. So next we're going to look at the second example. So square root of, we can do 3x squared minus 5x plus 2 equals 3x squared plus, sorry, not 3x squared. Let me make a correction here. We're going to have a 4x squared here and a 2x plus 1. Okay, so in this case, on the left-hand side, the square root is already by itself. We only have a square root sign. Notice that everything is within the radical sign. There's not a plus or minus on the outside of radical sign. So we can go ahead and square this square root and do the same thing to the right-hand side. Now on the left-hand side, this square and the square root, they cancel each other. We are going to get whatever within the radical sign, which is 4x squared minus 5x plus 2. Now on the right-hand side, we got to be a little bit careful. You cannot distribute the exponent to both of them because it's plus. We can only distribute the exponent when it's a multiplication or division in the base. So when we do this, we have to do 2x plus 1 times 2x plus 1, 2 copies. And you can either do FOIL or distribute. So on the right hand side, when we simplify that, we will get 2x times 2x, 4x squared. And 2x times positive 1, that's the 2x. And 1 times 2x, that's another 2x. And 1 times 1, which gives us a plus 1. Now let's combine like terms. Notice, let's go ahead and combine the like terms on the right-hand side first. So we have 4x squared, and these two can be combined, plus 4x plus 1. Now, what do we do next? And notice this has a x squared. We still have like terms that we can combine. So always try to combine as much as possible. So this and that is they're like terms, and these two are like terms. So we can combine these like terms with the variable x. And to combine them, we have to move one of them to the other side. So for example, I can move this to the left by subtracting 4x squared and 4x squared. And notice after we subtracting 4x squared, they cancel. So we end up with just 5 on the left hand side. That would be negative 5x plus 2 equals 4x plus 1. And now we can combine these two like terms. I can add 5x to both sides. And that gives me, they cancel. So we have a 2 on the left equals 4x plus 5x. That's 9x. Copy that plus 1. And now we get rid of this minus 1 by subtracting 1. And it gives us 1 equals 9x. And we divide both sides by 9. That gives us 1/9 equals x. So that would be the final answer. And again, we do need to plug 1/9 into both sides to verify this is the correct answer. You can use a calculator to do that part. If for some reason after we plug it in we don't get correct the answer there, then you call this a fake solution. You will have to say no solution.